Hi everyone, welcome back to Statistics and Data Analysis. Today we will keep going on descriptive statistics, and in particular we will talk about summarization. So descriptive statistics is a way for people to describe data, and roughly speaking we can separate those ideas into two groups. Last time we talked about how to do visualization with graphs, okay? And today we will do summarization with some numbers. So basically, once we get a few numbers or sometimes a lot of numbers, it's hard for us to get some ideas if we look at all the numbers. So we may want to use a few, one or just several numbers to do a summarization, so that once we look at those numbers, we can get some rough ideas. This is always the first step of any data analysis project. That's how we get some intuitions that may guide our directions of further study. So that's our topic today. Basically, for a set of numbers, we use a few numbers to summarize them. If we are talking about population data, then we want to find some parameters to do that. If we are talking about sample data, then we need statistics. Okay, we will talk about them in more details later. We will talk about three things today. We want to have some measurements of central tendency, which describes a center or the middle part of the data. Okay? Or we want to talk about variability, about how the data are variable, or how dispersed the data is. Finally, we want to have a measurement for correlation, so that we may somehow describe the relationship between two variables. So that's our plan today. So in the first video, let's talk about central tendency. Suppose that we are talking about this particular example with a baseball team with 20 players. Here, the records, the 20 numbers are their heights in centimeters. Okay, so you can see 20 numbers there. If we apply the methods we learned in the previous lecture, for example, if we want to draw a histogram, it will be something like this. And you can see this is exactly a histogram we introduced last time. We can see that, for example, most of the people falls in these three categories. Okay, and some people are quite short. But anyway, a graph, of course, gives you some ideas. Today, we want to describe the set of data with numbers. Let's first try to describe central tendency. What's that? It's about where is the center of the set of data. And regarding center, this concept, we will have a few definitions. The first way to describe a so-called center is to tell people the modes. Okay? And the modes, by definition, is or are the most frequently occurring values in a set of data. So that means in the previous example, when we are given 20 numbers, which number occurs the most? Okay, which number occurs the most? In that case, we say that number is a mode. Or in that particular example, if you do the counting one by one, you can see that there are three people whose height is 175 centimeters. And also there are three students, three players, their heights are 178 centimeters. So that means in this particular data set, we have two modes. Okay, two modes. Their values, the frequencies are 3, and the modes are 175 and 178. Obviously, sometimes you may also want to do this for qualitative data, okay? So for qualitative data. That's because if you don't do that, if you simply do the counting for quantitative or numeric data, then it's possible that all the values are modes because all the values occurs exactly once. Okay, so the concept of modes is better to be applied on qualitative data. Okay, so modes provides your first measurements for central tendency. Sometimes it's better to use some other measurements. Why? Mode has a few disadvantages. First, we said for numeric data it's not very easy to apply. And the second, there may be multiple modes, and in that case you don't really know how to interpret it. So for numeric or here for ordinal data, we sometimes would like to use medians. The median is the middle value in an ordered set of numbers. So roughly speaking, we first order all the numbers and then say a median has half of the numbers below it and half of the numbers above it. So the median is just located exactly at the half of the ordered data set. Suppose there are n numbers in total, then precisely we can say if n is odd, then the median would be this exactly number at the center point, n plus 1 over 2th large number. If n is even, then the median would be located as the average of the two middle number, okay, n over 2th and n over 2th plus 1th number. So let's use some examples to explain it. When we have 7 numbers like this, 7 plus 1 divided by 2 is 4. So the median is the 4th number, which is 5. You can see that half of the numbers are below it and half of the numbers are above it. When you only have 6 numbers, then your median locates at the center, right? At the location 3.5. And that means your median is defined to be the average of the middle two numbers, and in this case 4.5. Okay? Medians have a few priorities, and one of the most important things that we need to recognize is that a median is not affected by the magnitude of extreme values. For example, for these 7 numbers, the median is 5, right? Even if some numbers becomes extremely large or extremely small, well, that single adjustment does not change the median. The median is still 5, and you can see why. Basically, that's because we only care about the order of the data points. We don't really care about how large they are in some sense. That can be good in a sense that medians can also be calculated for ordinal data. If you have quantitative data, then all you need to do is to first order them and then start your counting up to the middle part. Or if you have ordinal data, then you can still do it. We will have some examples to show you. But basically, as long as you can order, you can rank all your data points, then you can calculate median. Median is making sense to you. On the other hand, if you have nominal data, then of course, because those categories do not have any order within them, then you should not use median to describe anything. That's just misleading. Unfortunately, a median is also in some sense bad because it only uses part of the information contained in those numbers. If you have quantitative data, you can do some arithmetics on it, but a median only treats them as ordinal. So you give up some information contained in your data set, and you only use part of the information to do the summarization for everything. That, of course, lose something. Okay? And that motivates us to adapt one further measurement. So mean. The mean of a set of data is just the average of a set of data. Actually, to be more precise, we should say is the arithmetic mean or the arithmetic average. Okay, so that means we sum up all the numbers and then divided it by the total amount of numbers. Okay, so the means, because we are doing addition, so it can be calculated only for quantitative data. Very quick example, when you have 7 numbers like this, the mean can be calculated with the formula like this, just as intuitive as what you always do. Then it would be 5. We can see that the mean uses all the information contained in the numbers. So that means it somehow gets a better summary of all the data. Okay, of all the data. That's typically a good thing. But of course, you can see, unfortunately, a mean will be affected by extreme values. Okay, like if you change 9 to be 900, then your average would be quite large. Okay, much larger than 5 in the previous case. So this exactly immediately tell you two things. First, we really need to worry about outliers or very extreme values before we calculate mean. Okay, because mean is affected by outliers. On the other hand, median does not. Okay, a median is not affected by outliers. So if you really want to summarize a set of data regarding central tendency, in many cases people suggest to write 2 numbers down. Tell people what's the mean and tell people what's the median. That can really help people understand more about the data set. Okay, sometimes they are very close to each other, sometimes not, but providing the 2 numbers at the same time can be useful. Okay, now you have means, the definition of means. One thing to be clarified, or one thing to tell you, is to distinguish population mean and the sample means. Let's first look at the formula. Suppose you have n numbers, and this capital N is the population size. So here we are talking about a population data set. Then the population mean is defined as mu, which is this formula, the sum of all the numbers divided by capital N. Suppose you have a set of sample data and the sample size is small n, then in this case we define the sample mean as x bar, which is the sum of n numbers divided by small n. Okay? Before we do further explanations, please keep in mind about these 2 symbols, mu and the x bar. In the world of statistics, almost always people use mu to denote population mean and use x bar to denote sample means. So that means in the future, if you write any kind of reports regarding population mean or sample mean, using these two symbols would be a best choice, because that allows people to understand what you are talking about. Do not try to use them to denote other quantities, because that's quite confusing. Also, capital N and small n are adapted by many people to denote population size and sample size. So just a suggestion, please keep using it when you talk about statistics at this part. Okay, obviously you have some questions. One would be, what's the point of defining these 2 things? In particular, their formula looks just identical, right? The only difference is that capital N and small n. So, are they just the same? Well, from the perspective of calculation, yes, the formula indeed is just the same. But in the later, when we talk about statistical inference, then the 2 things are just so different. One thing that you can understand at this moment would be the following. we know that the population mean typically is fixed because the population is just there. Okay? Now, if we want to ask what's the average height of all NTU students, all NTU students are there, and they all have height. So that population mean is just fixed, but unknown to us. So we would like to randomly select a few students and calculate the sample mean, the average height of all the randomly selected, let's say 100 students. That sample mean is actually random. So this is really different from population mean. Population mean is fixed. It's there. It's just that we don't know it. Sample mean is random. Today we get 100 students. Tomorrow we get another 100 students. That X bar would be different day by day, right? So X bar is somehow a random number. To use X bar to do inferential statistics to estimate or test mu, then we need some methods, we need some theory. Probability will be used and some methods will be given to you. At this moment, because we are still at the stage of descriptive statistics, when you want to use mean to describe a set of data, the formula is the same, no matter you are talking about population or sample. But in the future, when we do inference, then you need to keep in mind that the sample mean is random. It is used to estimate or to predict or to test the fixed population mean. Okay, please keep in mind. Lastly, we have quartiles and the percentiles. The median lies at the middle of the data. If we want to extend this idea, we say the first quartile lies at the middle of the first half of the data. The third quartile lies at the middle of the second half of the data. So when we talk about quartiles, we have 3 quartiles located at the 1/4, 1/2, and 3/4 place of the whole data set. Okay? If we want to further extend the idea, we actually can define percentile. For the pth percentile, we have p over 100 of the all the values below it, or the other way above it. Okay, so percentiles, in some sense, we can have the first percentile, second percentile, or something or something. Then by definition, the 25th percentile is the first quartile, right? The 50th percentile is the median, or you say the second quartile, or the 75th percentile is the third quartile. So having these numbers can somehow also help you in a sense that you can use them to, for example, support your description with mean or median. For example, if you provide median, that's just one number. If you also provide the first quartile and the third quartile, then the 3 numbers together may help you further describe your data set. So typically, mean and the median are used more often. When you feel that they are not enough, you may want to add quartiles or percentiles or even mode into your description. Okay, let's take a rest. Thank you.